All right, so let's talk about the MongoDB assignment. So this assignment is going to give us a chance to practice using the non-relational database MongoDB as a permanent storage solution. We're going to create a Node.js application that interacts with MongoDB database, and we're going to be able to store, retrieve, and update data that we store in there. This assignment is a follow-up to the previous assignment. In the previous assignment, which was the Node.js assignment, there we used Node.js to create several RESTful APIs that exposed several pieces of data, and that data was a list of quizzes that then were rendered by an Angular application. And then once you navigated to a quiz, you would retrieve a list of questions that were for that particular quiz, also hosted by Node.js. So Node.js created a RESTful APIs that allow you to retrieve the questions for a particular quiz. Now this data in the previous assignment was stored in hard-coded array files that contain arrays of quizzes, arrays of questions. So we're going to refactor that implementation, and instead I'm going to use MongoDB to host all that information, right? So we're going to have MongoDB have a collection that's going to keep track of all the quizzes. It's going to have a collection where it's going to have all the questions, and we're going to create Mongoose schemas that are going to describe the structure of the quizzes in terms of a collection of questions, right? And we're going to be able to retrieve them. So here's the first couple of things that you need to do is to first create a couple of quizzes and questions in Mongo. We'll do that today, and I'll show you how. But then to be able to use it from Mongoose, you're going to create Mongoose schemas, right, that are going to map to the questions that are stored in the database. Questions are going to have titles and the actual question, whether the questions are true, false, multiple choice, essay questions. If they are multiple choice, then they might have different options or choices to choose from. And then we're going to build a collection of quizzes that is going to be built in terms of an array of questions. Okay. So once we implement these schemas, we're going to add an additional schema that it's an addition to what we had in the previous assignment. We're going to have folks be able to submit the answers to a quiz. So in the previous assignment, we had it so that the student could select different answers for their true, false, or their multiple choice, and we had folks be able to grade their questions on the client, right? And we were not posting any of that information back to the server. So in this case, we are going to take all those answers, right, for the true, false, the multiple choice. We're going to grab the entire quiz. We're going to send it over to the server, and the server what it's going to do is it's going to grab this attempt, right, this quiz attempt, right, and it's going to store it in the database, right? It's going to store it. It's going to store a reference to the original quiz that this attempt refers to, and also it's going to store the original questions that were used to answer the questions in this particular quiz. So meaning it's going to take a copy of all the questions, the original questions, right, and all your answers, and is going to copy them into the database. Now you might be concerned and say, well, this might be redundant. We already have questions represented elsewhere. Why copy it? Well, the thing is that the questions, the original questions might change over time. I might find a spelling, or I might change one of the choices, one of the options. So we want to be able to keep track of a history of what the questions were originally, right? And so render them says, hey, these were the questions, this was your answer, and this is your score based on what the original question. So we want to keep track of all those copies. So that's why the answers are really the original questions, and those questions are also going to include the answers that you selected for that particular question. So notice that in the schema for the question, right, we are going to add a field here that keeps track of the answer that you gave for that particular question, and that's what's going to be used to store in the database. So we're going to have the schemas. We're going to implement the models for each one of those schemas, right, for the questions, for the quizzes, for the attempts, right? And these are going to provide the low-level CRUD operations that are going to allow us to interact with these collections, right? They're going to provide, functions such as find, create, update, remove, and these are all low-level generic functions, right, that allow us to interact with these collections. And that's fine. We are going to write all our data interaction in terms of those low-level CRUD operations. Now, usually it's a good practice to not use directly those low-level generic functions. Instead, it's a good practice to wrap those low-level functions in terms of a high-level API, right? That provide a domain-specific set of functions. Like, for instance, instead of using the find function all the time, instead we're going to wrap it inside of a higher level function and expose this to the rest of the application. So the application, whenever they want to interact with questions, quizzes, attempts, whatnot, they would always go through this object called a data access object, or DAO or DAO, right? That collects all these low-level functions and wraps them inside of a high-level API. Okay, so here's a find question by ID. Notice that it's specific to our domain of questions and quizzes, and it's written in terms of the lower level, more generic API that is provided by the Mongoose model. We're going to do that for every single Mongoose model. Same thing for the quizzes. Same thing for the quiz attempts. Now, for the quiz attempts, we're going to be able to send over and submit an attempt or submit a quiz, and so we're going to pass to the DAO. We're going to pass the original quiz ID and the attempts, which is going to be all the original questions with our answers, and we're going to store it in the quiz attempt models, right, in the collection, so that we have an audit of what, who answered what for what quiz, what were the answers, right, for each one of the quizzes. Now, when we submit, we're also going to calculate a score on how well did you do for that particular quiz, for those particular questions, and for that we're going to have a function that is going to iterate over all the questions, right? It's going to see what you answered, right? What you answered, is going to compare it against the correct answer. If they're the same, we're going to just count, how many times you were right, and we're going to calculate your score with a ratio of how many you got right versus how many questions there were in the quiz. Assuming that they all have the same weight, right? We're just going to multiply it by 100, and that's going to be your score, right? And that's going to be stored in the database. It says, well, these were the original questions. This is what you got in that quiz. So once we have all these DAOs, we're going to refactor some of the services we wrote in the previous assignment, right? In the previous assignment, we exposed the data that was stored in arrays, right? We exposed it through several services, right? We wrote the question service, we wrote the quizzes service, right? And they were all written in terms of these hard-coded arrays, right? So we're going to rewrite those so that instead of using these hard-coded arrays, they're going to go out to the database, right? So, for instance, find all questions used to be written in terms of just returning the array, the whole array, and find question by ID was written in terms of filtering the questions by the quiz ID and then returning those from the array of the questions. So we're going to rewrite those in terms of the DAOs that the new DAOs that we're going to write for this assignment, right? And in terms of the APIs, the high level APIs the DAO is providing, right? Some folks might say that this is an overkill. Notice that most of these functions are just pass-through functions, right? Notice that just find all questions is just doing DAO find all questions. Find question by ID is just calling find question by ID. Some might say, why the extra layer of abstraction, right? And in this particular case, you might be right. It might be an overkill. The services could. Yes.
Are you trying to screen share with us?
I'm not screen sharing.
No.
I love this class.
Yes, I was trying to screen share. Can you see my screen?
Yep.
Thank you. All right, where was I? Right, so some might say that there's writing this extra layer of abstraction of having these services, right? That they could have been written in terms of the controllers just using the DAOs directly or the Mongoose models directly, and that might be the case. Our implementation perhaps is fairly simple, and you might not need the extra layer of abstraction. But as a project grows and there might be more folks participating in the project, and it grows in complexity, these layers of abstraction allow you to implement principles such as division of concern, right? And where you might have certain folks working on the data layer, some folks working on the service layer, on the RESTful APIs, on the database models and whatnot in the schema. So again, even though this might be perhaps an overkill for what we're doing, I wanted to have an opportunity to show you, architecturally, how you might break out, fairly complex, larger applications. So it's a very common thing to do, to break out, the RESTful web tier, right? Then you have kind of like a business layer here with this using this service. Then the data layer, which would be the data access and the models and the schema. So it's a very common technique, to architect applications into multiple layers, especially when you start growing fairly complex. So they will have these services that are going to expose the access to the data layer. We are now, because these services are using these DAOs, and these DAOs are basically using the low level Mongoose models, right? All these queries, all these functions are now going to be asynchronous, right? Before, all these functions were synchronous, right? They were, the find all questions was just returning the array, right? And the find question by ID was just iterating over the array using a filter. But now they are implemented using the DAOs, which is now a synchronous call to the database. So we need to refactor all our controllers, right? Because they were written in terms of synchronous function calls, right? So we need to refactor them so that now they take into account the fact that these calls are now asynchronous, right? So for instance, the controllers that expose access to the questions and the controllers that expose access to the quiz, right? They were written so that the response was blocking, waiting for the service to come back, and whatever data came back, that's what the controller responded. Instead, we're going to have to rewrite it in terms of this. Now these functions returning not data, they're returning now promises, which we need to register for a callback, which is going to come back with the data, and then we can send it back as a response to the client. So we'll need to refactor those. So those two controls will need to be refactored. There will be a brand new control that we need to write for exposing the attempts, right? Being able to post the answers for a particular quiz, and for retrieving all the attempts previously from a previous quiz. Once we have the controls, we need to remember to register them all in our server and provide a reference to our app. So that's for the backend, right? For the controllers, services, DAOs, Mongoose models, and everything, right? We're also on the client side. We're also going to need to do a couple of refactoring steps. If you remember, we had in our quiz component, we were iterating over the list of quizzes. I'm sorry, we were iterating over the when you selected a particular quiz, we're iterating over the questions in a quiz, right? Over here, and then we were passing a reference to the question to multiple components, based on the question type, right? If it was a true false or a multiple choice, right? We were rendering either a true false component or a multiple choice component, and we were passing references to the question down to the component. Well, each one of these components was able to grade itself, right, and highlight whether you're correct, wrong, or whatnot. But now we need to be able to ask each one of these questions, what was the answer that was selected by the student, right? Collect all those answers, right? And then send all these answers back to the server and post and submit the quiz, right? So to do that, we're going to, if you remember, all these components had an answer variable in the component, right? Well, we're going to have to be able to expose that answer, right, so that it'd be available here as we're iterating over the questions, right? We're going to be able to, we have to be able to say, hey, what was the answer for question 1? What was the answer for question 2? And so on and so forth, right? We need to, we're going to grab that value and we're going to bind it to the answer variable for each one of the questions, right? So that when we submit the quiz, right, we can grab all those questions with the answers and send it over to the server, right, to submit and store in the database. Yes, right. So to do that, we had already bound the question, right? We were passing the question attributes, so we had done that already in the previous assignment. But the answer, right, we're going to have to do the same thing. We're going to have to expose that variable, that state variable that lives inside of these components. We're going to have to expose them out to the parent, right? So the way we're going to do that is we're going to use this input and output, right? That we're going to be able to receive the answer from the outside, just like we did for the question. But we're also going to be able to provide the answer that was selected to the outside, so we can receive the answer from the outside and we can send back changes to the answer, right? So we're going to emit an event saying, hey, I'm going to notify you if the answer changes, right? So as you're selecting the answer, we would like to notify the outside world and say, hey, the answer changed, here it is, bind it to wherever you need to, right? And then collect it so that you can send it over and post it to the server. So down below, we're going to also add a submit quiz function, right? That we're going to be able to click on a button, right? So that we can submit and send over all these answers. And the implementation is just going to be simple, right? We're going to post to our Node.js, right? We're going to say, hey, for this quiz, these are the attempts, right? These are all the answers that the student is submitting. We're going to grab all those questions, right? That it's the array locally that we use to iterate over, including the answers are inside of those quizzes, inside of those questions. And we're going to send all the arrays of questions with the answers inside, over to the server so that it can be posted and stored in the database. Okay. Also, another refactoring is that if you remember in the quiz component, that's where we iterate and show all the quizzes, and we can then navigate right here. This over here, right? This component here, the quizzes. Okay. For each quiz, we're going to underneath each one of the quizzes, we're going to display all the attempts. Right, when the attempt number 1, attempt number 2, the various attempts of the quizzes, and the score for each one of the quizzes. It's not displayed here. I'll add a picture of what it should look like, so you can know how to render it. So that's the assignment, the MongoDB assignment, and so let's take a look at how we would get started.